Hey guys, what's up? This is Rocky is back with another video, and in this video, I'll be talking about replacing antonyms in NLTK. So basically, what we'll be doing is let's say, we'll be replacing words which are negating something with a proper antonym. So let's say over here, for example, this is just a demonstration. So I'm using something called antonym replacer, which is not given along with NLTK. You have to construct it. And how do you construct it? I'll show you over here, but this is going to take a bit long. Anyways, it's quite simple, so I hope that you guys sit and watch this. So it's pretty simple. You don't have to worry about that. So if you've not watched the previous videos where I have covered regex replacer and repeat replacer and also word replacer, which is nothing but replacing synonyms, you go ahead and watch that first and come back so that you have a grip on a lot of things that I've discussed over here. How you can import certain modules and then import this itself, this module called example replacer and all that. But of course, if you're not interested or if you've already watched it, I'll just say that you can skip these two lines and you can delete them. You don't have to use that. Or I'll wait a second. So I'm using WordNet over here. So I'm sorry. Yeah, you have to use these two lines, but import RE can go and you can delete. You can ignore all these lines of code, and all you need to focus on is about the class called antonym replacer. So anyways, what is antonym replacer? What does it do? So let's say I have something called antonym replacer. I'll not talk about this yet. So let's treat it as a black box. So antonym replacer, I'm just creating something called rep, which is replacer or anything. So if you remember, we instantiate objects using classes. We have been doing that for a long time. So if you remember, we can do word tokenizer, sentence tokenizer, stuff like that. We have done in the first few videos. So similarly, what I'm doing is instantiating something, and then I'm just saying QW. You can call it anything. So let's say, what do you? I'm really bad with words, so let's say jar word or something like that. I know it's pretty random. So what's happening here is, let's say jar word is assigned to the this thing. So it's saying rip dot replace cowardice. So cowardice is basically a word which you already know. So when I build it, what it's giving me back is courage. So basically what it's doing is it's just giving me back the antonym of cowardice. So whatever is not cowardice is courage. So it is basically giving me back. And if you remember, in my 6th video in this series, I spoke about antonyms as well when I was speaking about synonyms, synsets, and stuff like that. We spoke about lemmas and stuff and all that. If you have not watched it, I again urge you to go ahead and watch that because it will give you a foundation. And this time, I think that is a bit more important. You need not watch all these to understand this video, but I think you should understand the concept of lemmas, antonyms, and synsets, all these things which I covered in the 6th video. So anyways, okay. So if you remember in the 6th video, I did something like this. I also I mentioned that we have 4 lines of codes. 4 cycles. So over here, what happens is, okay, so how this is working is basically this class has been initiated, and then the replace method is as follows. It will take self as the first argument as usual, which is for every method, and word is the second argument. So when I pass a first word, what it is doing is it is creating an antonym set. So set is nothing but let's print it out and show it to you. So I'll just say set is antonyms. So let's see what happens. All right. Oops. Okay. I can't just print. Oh shit, man. Can't just print it like this because one is a string and the other one is a set. Alright, anyways, it's just giving me a set. So a set is basically just like an array, but it's much more refined. You know what a set is, so I don't have to explain that. Anyways, I'll just delete this. So antonyms is a set. So for what the for loop says is for sin, which is nothing but a sin set. For sin in wordnet.sin sets word. So this is returning the sin sets, sin set. So if you remember, we use this notation wordnet.sin sets and pass a word to get back a sin set. So if you remember, we have done that in all these videos, 5th, 6th, 7th, 8th, or so on, something like that. And I hope you remember. So you get back synset, and each synset has a lemma. So and sometimes it can have multiple lemmas. So what we're saying is for lemma in synset dot lemma, so sin dot lemmas, whichever. So for each lemma, find out an antonym. And how do you do that? Is each lemma comes with a set of antonyms. You can just call it as lemma dot antonyms method. And for each antonym in lemma dot antonyms, what we're doing is we're adding it to the antonyms set. So whichever set we have created here, these antonyms are getting pushed into it. All right. So that's the most important part, and that's it. We're done. What the next set of lines is that it's like it's saying if the number of antonyms in my whatever collection is equal to 1, then do something, and if it is not, then just return none. So what it is saying is if it is 1, then it is returning whatever that antonym is by popping it out. So pop is a basic method. If you know Python, you know it. So if you don't, what it means is take the set and take the last element and just pop it out. So that's what popping is. You can pop an array, you can pop a set and stuff like that. Anyways, so if not, return none. So basically why we need this to hold to be true and not greater than or equal to 1 is that sometimes a word can have many antonyms. Alright, so a word can be interpreted in many ways. So because of which you can't generally say, this antonym, this guy's antonym is this. You would have to you would have to either give all the antonyms, or you would have to, just say I can't do this job. And the reason we are saying return none is because we are using this function inside another function, the next function, which I'll be talking about, but just wait a bit. So that's why when I say print jar word, right, I'll just say j word instead of jar word. All right. So when I say print Java, what it's doing is it is doing all this. I mean, it's evaluating all these set of functions and then just giving me back the answer. So when I say cover this, when I build it, so let's see what it says. All right, so it says courage. Similarly, but if I give thin, so it appears that when I say thin, let me build it. See, I'm getting back none because thin has many, antonyms, because thin can be interpreted in many ways. So that is why it is not able to give it back. So let's test for thick. Let's see what we get. So we are getting none again. So I was testing for a lot of things and I found that these 3 words were quick ones which I could demonstrate. So if I give heavy, I get light as the answer. So let's see. All right, so as you can see, I am getting light as the answer. So this is how it works. It's simple. It's quite, simple. But now after this, I mean, whatever I commented out over here, that is the next most interesting part. So right now, let's say I am submitting a sentence and I'm saying this is not something, right? So if I'm doing that, now I want it to be replaced. I mean, the not weak should be replaced with whatever is appropriate. So let's run this and see what happens. All right, so as you can see over here, we are getting this is strong, but of course we are getting it in an array format, and there's a reason for that. I'll explain all that. So what is happening is here we were using replace, but here we are using neg replace. which means it will pick out, I mean, this is just my own name, so you can name it anything. So it will pick out whatever is not something, and it will just, you know, replace the not something with the appropriate set of words. So how is the stuff, I mean, how is it doing it in the background? So let's go back to this file and let's see the neg replace over here. So alright, this is a simple function. So what it takes is self as the first, the first argument as usual, because all definitions inside a class need to take self, because when they are instantiated, so on so on. I have explained this in the previous videos, so it's not important as well. I mean, just make sure that you're putting a self. So after this, you give a string. All right. So the string is tokenized into an array of sent. So for that to happen, you need to have NLTK dot tokenize import word underscore tokenize. All right, to be able to use word underscore tokenize, make sure that you have this, and also make sure that you have this for using wordnet, which was required for this initial replace function itself. So the neg replace function, how it works is that you have a sent, I mean, you have a string which you pass, which is nothing but the sentence, and then we are making it an array. So what we are doing is word underscore tokenize. If you remember, it will bring back all, I mean, it will tokenize each and every element, each and every word, and then length underscore sentence. So len sent is nothing but the length of the array. So it'll just register, let us say 5 or 6 or something like that. And then we're also declaring, initializing something called words, which is an empty array. So we'll be dumping everything, dumping whatever stuff goes on. I mean, all whatever is returned, it will be dumped inside this words, and that will be returned back in this format, as you can see. So we have a while loop, which is the most important part of this. So what it is saying is, while I currently understand that I is equal to 0. So what it's saying is, while I is less than length of sentence, what I want you to do is word is equal to sent I. I mean, so it is saying for now the word is sent I, and if word is not and I plus 1 is less than len sent. So what is happening here is it is checking for not, whether if it is not or not, because it has to check whether I mean, not followed by something. So what it has to do is, let's say, it has to see, okay, not followed by weak, right? So it has to see whether this is not or not. So that, because it can't just replace this this is whatever we have built is meant to replace it, not weak. So what it has to do is it has to check for not, and not only that, it has to check that it's not like this. It's not like not is the last element, because when we do this, what happens is we just get this is not, because we can't just replace not into something, because it doesn't exist a word for just, it's not, so yeah, it's something like that. So what happens is we just have to make sure about that. So that is why we write and also this condition. All right, so what we say is ant is equal to self dot replace sent I plus 1. So I plus 1 is basically the the next element after not. And so if ant means that if this has been successful, basically if it gives back none, so then this won't be running. So if word is equal to not, then this will run, and the second if condition will run only if this antonym has been successfully been found, and also the length of it is 1, because that will, it can be found only if the length is 1, or else it'll just return none. So if you have 0 or 2 or more, then you have a problem, but if it is only 1, then you're good to go. So what it is saying is words.append ant, and then what it is doing is it's just filling the words into it, and it is it is running the number of counter. The which is a counter over here. It is it's postponing it I mean, it is placing it by two places. I mean, it's moving it by two places. That is because we have dealt with not as well as weak, and we have to go to the next word if at all there is one. So that's why we have continue as well. So having a continue here allows us to, just directly go back to the while loop without taking care of any other statements. So let's say if it is not ant, or if it is not word, what happens is, if this is, I mean, if this is not, if the word is not, then what happens it's just it just takes the word and just appends it. It just drops in. So for example, it sees this. Okay, this is not, so it'll just say this again, and is again, and next it'll see, okay, this is not. Okay, so then I have to check for the next one. So it'll check for week, and it'll see if it is if there is something, if there is a antonym, a proper antonym for week, and then it'll check. And when it checks, it finds out proper response, proper antonym, and then it'll replace these two things. I mean, it won't replace these two things. It'll just take that word and it'll just push it in. So you're getting strong over here. And then you have I plus is equal to 1, which is a proper you know count, I mean increment which you use. So that's how this works. So it'll return the whole words array, and that is why you get back the sentence. So that's it, guys. So I hope you understood the whole thing. So it's basically, it'll take this and it'll do all the magic inside, and then it'll give you back this is strong. And lastly, if you don't want this array, and if you want the sentence, it's simple. You just, what you need to do is, uh, okay, let's see. Okay, so what you need to do is, out of the while loop, what you need to do is, sentence is equal to, okay, inside the while loop itself you can do all these things, but all right, so we can construct another for loop. It's not a big deal, but we can also do it inside over here as well. Let's do it inside here itself. So when we are appending it, all right, so yeah, let's do it over here itself. So what we are doing over here is, let's take a sentence. Let's take a final sentence. F sent. I initialize it to something, so it's a null right now. So what I'll say is f sent plus equal to ant, and what I'll say is f sent plus equal to word over here. Oops. So word over here, and yeah, that's about it. So I'll just send back f sent. All right, sorry about this. So you have to add spaces as well. So yeah. So let's see what we get back. All right. So as you can see over here, I'm getting back a direct happy sentence. So this is not weak is coming back as this is strong. But there's one problem with this, guys. If I give a full stop, a full stop would have to come back with the space over here. So that's one issue which you need to work on. I mean, it's pretty simple. You need to check if it is a full stop, and if it is a full stop, you have to not give a space and stuff like that, which is all boring and monotonous. So I'm not going to cover it over here. But anyways, I hope you understood what we have discovered today. So it's basic, it's simple. So you can also say stuff like I am so heavy. Sorry, I am not heavy. All right, so let's see what happens. All right, so I'm getting back I am light, but with a space as well, which is a bit disappointing, but it's okay. It's fine. You can manage with that. So if not this, let's say he is he's not weak. So you get back he is strong. So let's see. All right, so he's getting I'm getting he is strong. And then lastly, mm, man is built. Mm, okay. Uh, his virtue is not cowardice. Right, let's see what happens over here. All right, as you can see, his virtue is courage. So that's it, guys. So as you can see, this is working pretty much fine. So you can use all these things, and if you want this code base instead of typing it out, just comment out. I'll be happy to give it. I mean, I don't mind because this is not my stuff anyway. I've been reading it from various sources and coming up with these things. So that's it for this video, guys. If you like this video, just give a thumbs up, and if you like to share it with your friends, please do share it, and also subscribe to my channel so that I can grow better and I can make much more tutorials so that you can understand more amazing things. Alright guys, thanks a lot for watching. This is DeRaze signing off. Bye bye.